So here's a quick little video of an overview of how I got my turret to work. Why don't I go ahead and show you what happens when I press play. Alright, so you can see my turret is going back and forth in sentry mode, like so. When I get close enough, it follows me and lights me up, like so. When I go back out of its range, it goes back into scan mode, as I like to call it. Alright, so how do I do this? How do you do this? Well, the first thing you're going to do is create or bring your turret prefab into your scene right here. And you'll notice that the prefab I already have for you guys, the turret gun and turret base have custom colliders on them that I just modeled out in Maya. That way we can get accurate hit detection on them. So when you shoot bullets into them and bullet holes, they'll spawn they'll register in a more logical manner. I didn't want to do a full mesh collider on these things because there are a lot of polygons of these, and just doing a spherical or box collider wouldn't be ideal either because bullet holes on them would just show up floating in midair, and it wouldn't be accurate hit detection. So I already went ahead and set that up for you guys. The next thing I did was place a raycast spawn in the tip of my gun here. This is where we instantiate all of our raycasts and where we spawn all of our bullets to come out of this guy right here. So let's bring up the script real quick. Here's my turret script. And I'm just going to walk us through it real quickly. Here are all the variables I've used. I have a boolean to flag whether or not the player's in sight. And if we come down to the first two functions I have a void on trigger enter that says if the other game object is a player, then the player in sight will turn to true, and we set our target to other, which is the player that's just come into our field of view. And the field of view for my turret, I just did a simple, for right now, box collider in front of it. You can do a lot of things with how you want your turret to detect people. You can make your own custom model inside of Maya in the shape of like a triangle or a cone or whatnot, and then use that model, that mesh, in your turret prefab. You can just place that mesh in here, turn off the mesh renderer, and give it a mesh collider, and that way you'll have a more controllable custom range in which the turret can find somebody. Or you can just do a 360. You can do a 360, player in sight collider trigger. All right, and then I have the three variables that control my burst fire, fire rate, and burst interval, and that's basically almost the same function as fire as we had for our player. There might be a few differences here. I think what I did, since the turret will continuously fire and our recoil still works for our turret here, after my yield return new wait for seconds, I reset the location or the rotation of my recast position after every burst interval. So what I'm doing basically with my turret is I'm having it shoot 20 bullets in its burst, and every 0.5 seconds it shoots out another shot in its burst number. So 20 shots every 0.05 seconds, and then every 1.5 seconds the burst fire is done and it starts a new burst fire. So whenever that new burst fire takes over, denoted by this fire rate, it resets its accuracy so the turret doesn't just get too inaccurate, because that range, as you can see, I gave it a very high accuracy, meaning that its accuracy is not good. That accuracy can really go all over the place. So just outside of my for loop right here, our for loop controls our burst, remember? So outside of my for loop, I just put a raycast.transform.local rotation, and I set it back to 0, which is quaternion identity right there. All right. So that's basically all for the fire function. You can pretty much just copy and paste this from your player fire. There's one bit more line of code right here, and that's saying if we hit the player with our bullets, then we don't want to instantiate a bullet hole on them, because then you'll just have bullet holes floating in space as you're moving around. So the collider checks to see if it's not the player, and if it's not the player, it'll instantiate the bullet hole. So if it is the player, this line of code won't occur, which instantiates our bullet holes. All right. And bullet distance is the same. That basically just says how far our ray travels that detects hits on our objects. Accuracy is the same as our player fire. Scan speed and aim speed. These two guys dictate how fast it scans back and forth whenever the turret is idle. And then how fast aim speed denotes how fast our turret tracks our player whenever we step in range of our turret. All right. And I have a bunch of game objects listed here. I'm going to go ahead and minimize this a little bit. All right. Our turret gun object is our actual top half of our turret. We need to get at this so we can add rotation to it. So just that part right there. Our ray cast position is basically our spawn point for our rays. I have a game object target for whenever our player walks into range of my turret, then it sets the target to our player. Object hit is the same thing we kind of had in our player fire, meaning we just have a public game object that denotes what our ray is actually hitting at the moment. And then bullet and bullet hole, again, same thing that we had in our player. I have two vector 3s, a left scan and right scan. So if I go to my turret here, I have left scan and right scan, and since they're vectors, it gives 3 different values for X, Y, and Z. I only deal with my Y value in these 2 scans. And basically what this denotes is, you can see up here at 35, I have a nice right scan bookend, and negative 35 is my left side bookend. So it ping pongs between left scan and right scan. And you can dictate how far you want your scans to be by moving the actual turret gun object and seeing what the value is in your transform layer up here. Wow, I just made that huge. All right, so we got some private variables going on now. We'll need a timer for our fire function, and private variables for our current accuracy X and Y to give recoil to our gun, give it some inaccuracy. This is one right here is new. This is a private float called ping pong. This is the value that denotes the value. Basically, it's used whenever we're scanning left and right with our turret here. All right. And I have a private vector 3 recoil angle. That's the same kind of variable we used in our player fire, so nothing new right there. Aim direction is a new one. This helps us lerp or linearly interpolate between where our player currently is and where our turret's going to be pointing. So you can see a nice linear interpolation as the turret follows our player, like so. All right. And we have a private quaternion that's also used with the tracking of our player target as we fire at it. So why don't we just walk through how we can get our turret to ping pong left and right as it scans, and how we can get it to follow our player. All right, the first thing we're going to do is we're going to have to make use of our player in sight boolean right here. So we're going to say if player is not in sight, so if player exclamation equal true, meaning our player is not in sight, then that's when we want to scan left and right. So we set a value to our private ping pong variable I just talked about, and we use a new math function called ping pong. Basically, this line of code takes a float value and goes up and down its value. So it goes from 0 to a value back and forth, back and forth. So this float is constantly growing and shrinking using this line of code right here. So now that we got a value that constantly shrinks and grows, we're going to take our turret gun object that we assigned up here in our variables right here, our turret gun object, and we just drag and dropped our turret gun top half right onto our turret gun object. And we get at its transform local Euler angles. Local Euler angles is basically a way where we can take vectors and convert those vectors into rotational angles, so basically quaternions. So anytime you're kind of working with vector 3 controlling your angles, you're going to be working with Eulers. Don't ask me the math behind it. It's really complicated. All I know from the years I've been programming with Unity, all I know is that Eulers kind of work with vectors. And we can see that we're setting our Euler angles for our top half of our turret. We're using a vector 3 lerp, and we're going from our left scan vector to our right scan vector over our ping pong value. So basically we're ping ponging between our left scan and right scan with this vector 3 lerp right there. So that's how we get our turret to ping pong and scan left and right. So if our player is in sight, I kind of have my ping pong set you to 0.5. I don't think you need that, so I'm going to delete that. Not necessary. I was just playing around with something right there. So if our player's in sight, we need to do a few things. We need to solve for two different variables. First, we need to get a vector that points at where our current player is. Okay? And we take our target transform position, which is the player, and we subtract it by the position of our turret gun object. So the top half of our turret, the gun part of our turret. So we take these two values and subtract them from each other. And then we do a dot normalized because aim direction, basically this normalized takes this subtraction equation right here and normalizes it to give us one new vector. All right, so aim direction is now solved for. We know the vector in which we need to point towards. Now we need to get the aim rotation by doing a quaternion look at rotation, and then we use our aim vector to figure out the angle that we need to set our rotation to. So this line of code finds the vector or the direction pretty much in which we need to face. This line of code controls our rotation to match our aim direction vector. So aim rotation equals quaternion dot look rotation, and then we use our aim direction right there. All right, so how do we actually get our turret to move now? We've got two values that we've used to find where our player is so our turret can look at our player, but we haven't actually moved our turret yet. We're going to use a quaternion slurp here. So basically how this works is we take our turret gun object's rotation, and we're gonna mess with our turret's rotation, right? Because we want to rotate our gun towards our player. So we use a quaternion slurp, and then we take our current rotation of our gun, and then we want to go to our current aim rotation, which we saw for right here, and we want to do it over time, that delta time, and then multiply that by our aim speed. And this slurp right here will smoothly track our player whenever we're in range. And before we call our fire routine, we need to give some random values to our accuracy. Same thing as we did in our shooting player shoot script. Before we call fire, right before it, we're going to say our current accuracy are these ranges. And we only have one accuracy variable this time since the turret doesn't have an aim or hip fire accuracy. We're just going to use a simple accuracy. And then from right here, we just call our fire routine that we've used with our player fire. So I think I've covered pretty much everything here. I'll just kind of scroll through the code one more time so you can get a feel for it. Feel free to copy it if you want. Okay, so now that you got to look at the code, why don't we just go through and see how I got the variables on my turret set up one more time. Here's my player in sight boolean. It's false. I'm going to press play. Our turret's in scan mode. As soon as I walk into the field of fire, player in sight equals true. We're shooting 20 bullets for every burst. So 20 bullets, 20 bullets, 20 bullets. All right. And then our fire rate and burst interval kind of are set up like that. Remember, we're shooting 20 bullets in a fast burst, so we can reset the position and rotation of our spawn raycast, our raycast spawn location, so the accuracy just doesn't get completely terrible. And then bullet distance is how far our ray travels, which I have at 100. My accuracy right here is really high because I want my turret to be somewhat inaccurate, so I can maybe dodge some of its bullets because it's firing really fast. My scan speed is how fast it goes left and right, so I can set this to be pretty low. Let me get the turret in view so I can make it really fast by increasing the scan speed, or I can make it really slow. All right, our aim speed dictates how fast the turret tracks our player. So look how it gradually tracks my player there. If I set my aim speed up to maybe like 5, let's see how fast the turret tracks to our location now. A little bit faster. All right. And then our game objects are like, a turret game object, so we can get at the rotation of our gun. We just take our turret gun prefab and slide it over there. And we put in our raycast spawn into our raycast position so we know where to cast and instantiate our bullets and raycast from. Target and object hit. Our target is always going to be our player when we walk into our field of view of our turret. So it immediately turns the FPS target, and then I walk out. It goes back to none. I think I might have that set to like null. Let's see. How do I do that? I might just do null. Okay, there we go. When I do my on trigger exit, I set my target to null. That way, my turret just doesn't have a target. Kind of maybe unnecessary, but that's what I chose to do, so I get for more readability inside my inspector while I was debugging. All right, so I think I've explained everything. If there are any questions about the turret, just let me know. Just give it a good try. And the next video, I'll go through and showcase my sample little scene in which I show combat with the turret. I might have some UI elements going on for you, and you can see how I interact with my console to unlock the door to my exit. Okay.